$3.1 billion, 96 floors, the tallest residential tower in the Western Hemisphere, with a 10-inch crack now running through its core. 432 Park Avenue was built to last centuries. Its architect is dead, its developer foreclosed, its Saudi billionaire penthouse owner never moved in. And the condo board stands accused of concealing nearly 2,000 defects. This tower is sinking, and the reason starts with physics. 10-inch fissure now cuts through the heart of 432 Park Avenue, a building once hailed as the ultimate symbol of Manhattan's luxury and ambition. This isn't a hairline crack in a wall or a cosmetic blemish. According to a 2025 court filing, the split runs deep inside the tower's 30-foot square concrete core, the very structure designed to hold up all 96 floors and resist the constant push and pull of wind nearly 1,400 feet above the street. The core's walls, each 2.5 feet thick, were engineered to channel every force, gravity, wind, and seismic tremor straight down to Manhattan's bedrock. Now, that same core stands accused of failing its most basic duty, staying intact. The discovery of the crack sent shockwaves through the city's real estate world. The lawsuit describes inspectors finding the fissure during an internal review, with condo owners demanding urgent repairs and accusing the developer of downplaying the danger. The complaint alleges a breach running 10 inches, a size that suggests much more than a surface flaw. Engineers warn that any discontinuity in the core could disrupt how the building distributes stress, especially in a tower that relies so heavily on its central spine to resist wind. Developer Harry Macklowe and architect Raphael Vignoli once promised a structure built to last centuries, but the presence of such a crack raises immediate questions about design, materials, and oversight. The $3.1 billion tower's reputation, already battered by reports of water leaks, mechanical failures, and legal battles, now hangs on the integrity of a single concrete wall. In skyscraper engineering, the core is meant to be invulnerable. At 432 Park, it's become a warning sign. A tower as slender as 432 Park Avenue doesn't just scrape the sky, it flirts with the very edge of what physics will tolerate. The building's proportions are extreme, a height-to-width ratio of 15:1, far surpassing the 12:1 threshold that engineers once considered the upper limit for residential towers. For a structure rising nearly 1,400 feet, that means even minor imperfections can ripple through the entire frame. Wind is the ever-present adversary. As air streams past the narrow profile, it creates swirling vortices that tug at the building in rhythmic pulses. Computational fluid dynamics studies mapped out these forces, revealing how the natural sway period, about 8 seconds for this tower, aligns dangerously close to the frequency of those wind gusts. When the rhythms match, the motion amplifies, causing the top floors to drift several inches side to side. Residents have described the sensation as unsettling, even nauseating on the highest floors. To counter this, the design team installed a system of steel outriggers at the 57th, 68th, and 79th floors. These trusses tie the concrete core to the outer columns, stiffening the whole structure and distributing the wind's push. Still, the most dramatic defense sits near the crown. 2 tuned mass dampers, each weighing 660 tons, perched between the 86th and 89th floors. These giant counterweights swing in opposition to the building's movement, absorbing energy and reducing oscillation. Their anchorage runs deep. 60 rock anchors drilled straight into Manhattan bedrock hold the entire structure in place. One wind engineer summed up the challenge. At this scale, a small miscalculation in sway control becomes a big problem for comfort and a bigger problem for structural safety. In a tower this slender, the line between comfort and catastrophe is measured in fractions of an inch. Raphael Vignoli's vision for 432 Park Avenue demanded a pure, luminous white facade, an aesthetic choice that would set the tower apart on the skyline and in marketing brochures. To achieve this look, the design team specified a high-strength white Portland cement mix, rejecting the typical grey blend used in most skyscrapers. The decision went beyond colour. Standard concrete recipes often include fly ash, a byproduct that strengthens the material, reduces cracking, and slows water absorption. At 432 Park, fly ash was excluded to keep the concrete from turning grey, saving an estimated $2 million in materials and labour. Internal emails reveal that this move raised red flags even before the first pour. BASF's lead chemist, Andreas Celebidis, described the resulting mix as a very fussy cake, warning that the concrete would be brittle and difficult to work with at the required 13,000 psi strength. To compensate for the lack of fly ash, the team relied on an elastomeric sealant and Isotech 8501 silane gel, a waterproofing system intended to block moisture from seeping into the concrete. But the sealant itself was untested at this scale and, according to later complaints, changed the color of the facade and masked early signs of distress. Internal memos from the construction phase document concerns that the sealant might only hide cracks, not prevent them, especially as the building flexed in the wind. The pursuit of a flawless white surface set up a trade-off between visual perfection and long-term durability. As residents would eventually discover, these choices had consequences that could not be covered up by any coating. The cracks and leaks that followed were not just the result of bad luck or extreme weather. They were the predictable outcome of a material gamble made in the name of prestige. In the end, physics never loses. It just sends the bill late. A cascade of failures began to surface soon after residents moved in. In 2017, a torrent of water poured through the walls of a luxury unit owned by Juan Beckman Vidal. The flood forced a return of his $11 million deposit and set off a lengthy legal dispute. A year later, a pipe burst on a high floor, sending water down elevator shafts and through electrical rooms. Damage estimates for that incident alone reached $9.7 million. Elevators, already strained by the building's height and constant sway, stalled with residents trapped inside. In 2019, one entrapment lasted 45 minutes before firefighters could pry open the doors. Then, in 2021, an arc flash in the electrical system plunged parts of the tower into darkness, raising fears of fire and further mechanical breakdowns. Each event left behind not just repair bills, but a growing sense of unease among owners. Testimony from Beckman Vidal described the building as uninhabitable at times, a far cry from the promise of flawless, uninterrupted luxury. Confidential engineering survey, quietly commissioned by the Condo Board, catalogued 1,893 separate defects in the concrete facade and structural core, an inventory that went far beyond routine maintenance. Internal emails and board memos, later submitted as court evidence, described mounting pressure to keep these findings out of public view. Sales brochures were quietly revised, removing language about total structural integrity and adding vague warnings of possible structural movement. One excerpt from the lawsuit alleges that after the defects were discovered, the developer altered marketing documents to downplay risk and delayed disclosure of the most serious issues. The same complaint claims the building's load-bearing capacity dropped by 12%, a figure that, if confirmed, would mean the structure no longer meets its original engineering standards. In May 2025, the board filed a $165 million suit, accusing the developer and architect of knowingly concealing the full extent of the damage. Their attorney points to emails advising staff to avoid discussing cracks with potential buyers. The legal fight now centers on whether these omissions rise to the level of fraud or are simply the fallout of a high-stakes gamble with concrete and wind. As the lawsuit moves forward, one fact remains: physics never loses. It just sends the bill late. The collapse in confidence at 432 Park Avenue hit hardest in the resale market. The penthouse, once listed at $169 million, languished without a buyer and was eventually relisted for $105 million, a cut of nearly 40%. This wasn't an isolated case. Thomas Petterfy, one of the building's most prominent owners, sold his 84th floor apartment for $13.5 million, swallowing a 40% loss compared to his original purchase price. Across the tower, the average price per square foot slid from $9,800 at the peak to $7,400 by 2025, erasing tens of millions from the value of each home. Foreclosure data shows multiple units seized by lenders as owners walked away. Meanwhile, the condo board's repair estimate ballooned to $200 million, a sum now at the center of legal battles over who should pay. For many investors, the promise of ultra-luxury living has been replaced by the reality of mounting losses and a repair bill that keeps growing. At 432 Park Avenue, physics never loses. It just sends the bill late. Today, lawsuits and repairs climb as engineers confront the limits of design ambition and material reality. In a city racing ever taller, physics sets the rules and ignores the marketing. No matter the lawsuits, the lesson stands. Physics never loses, it just sends the bill late.